9. Okay. See. Okay. Oh, someone joined. Okay. Hello, people. Sorry. These settings. Hi, Diane. Good to see you guys. So, just a reminder, the test will be next Monday unless you have an objection. So the test is next Monday. That would be May 11th. Unless you have another test. Okay. If you have another test that day, just let me know. Okay. That means that this week we're going to cover 12.6, 12.7, and then we're going to review. Okay? Okay, let's begin. Adding and subtracting rational expressions. Now the thing with adding and subtracting rational expressions is we actually have done this before. It's science test. I'll talk to your science teacher since he's the only other person on campus. Okay. Hi, Woonju. It's good to see you too. Yeah, I'll check that. Okay. So let's say we had these two fractions right here. Now, how would you know how to add them or subtract them? So if we were just adding or subtracting, what would we do? Well, we need to get the same denominator. Okay, we can't add them unless they have the same denominator. So how do we get the same denominator? Well, we have to see what's our least common denominator, which is also, so least common denominator. Or we need to see our least common multiple. It's the same thing for the purpose of this, but it's important. Okay, and the idea behind this is we're seeing the smallest number that 3 and 39 go into, or you could say go into, or are factors of. Okay? So, so the idea is the least common denominator is the smallest number, 3 and 39. Greatest common multiple, no, it's greatest common divisor, not greatest common multiple. Greatest common multiple would be like, say, what's the biggest number 3 and 39 go into? That's huge. So least means smallest. So smallest possible number both numbers go into. So in this case, is 3 a factor of 39? Yeah, 3 is one of the factors. So actually, our least common denominator is going to be 39. So then we multiply what is required. So 3, now greatest is biggest, and multiple means product. So greatest product keeps going. So essentially, greatest product can keep getting bigger and bigger. Okay. Okay. We're not going to go with that one. So we need to see what 3 needs to multiply by, and that's 13. So we multiply 13 on top and bottom. 13 on top gives us 26. Now, this is standard practice, not basic. This is standard practice with fractions. And then we just add, if the denominators are the same, we add the top. So we get 37. Okay? Now this principle is going to be what we're covering today. This idea, but with rational expressions. Rational expression means we're dealing with x, with y, with z, with w, and with polynomials of all shapes and sizes. Okay? So, polynomials. If a, b, and c are polynomials, and c is not equal to 0, we're going to have c in the denominator. So a over c plus b over c. Then as our rule with fractions, it's going to be a plus b over c. Okay? And what about subtraction? Well, subtraction is going to follow the same principle as addition, and we are going to get it all over c. Okay? If we take an example, so we have 2 over x plus 3 over x. We just add the top, so we get 5 over x. Okay? And the book also uses 5 over 4x minus 2 over 4x is going to give us 3 over 4x. So again, you're just adding the top, okay? So the reason why we want the smallest is because the smallest will always give us the simplest. We want the simplest form, okay? So our first problems are actually going to be, thankfully, the same denominator. But as you know with any math, the first problems are the ones to introduce the concept. As we go, the concept gets more challenging. Okay? So we have 5 over 3x plus 7 over 3x. Is the denominator the same? Yeah? So then 5 plus 7, which would be 12 over 3x. Now can we simplify this? Yes. See, 12 and 3 can be simplified to be 4, 1, so 4 over x. So you do need to write it in simplest form. Doesn't necessarily have to get harder. It just said more complex. I didn't say necessarily harder. I don't think necessarily harder, just more complex. Concept will start with basics, the fundamentals, and then it will build. Okay, in this example, it's subtraction. So this would be 3x minus x plus 5. Now, you could just subtract it immediately, if you can see it. So 3x minus x is going to give us 2x and then minus 5 because the negative distributes. So x minus 1. And in this case, you wouldn't simplify because they're not multiplication. Okay? So let's practice some. Practice 2 problems. We might actually, well, yeah. So this says find the sum or difference to y plus 1 over y. And then also 4x plus 1 sometimes people let it out. 2x minus 1. Okay? Let's try this out. So find the sum or difference. Okay, find the difference down here, find the sum up here. So what's the sum for the top? What's the difference for the bottom? I'll give you about, say, 30 seconds since it's just, there's no extra steps, it's just straight. Yeah, straight doing it. Okay. That was a little longer, but that was because you said that sound. So the sum of the top, 2 plus y plus 1, would become y plus 3 over y. Okay, again, you cannot simplify this. This is going to stay the same because this is addition, and only time we can simplify it is if it is multiplication. Okay, the bottom one, you can rewrite it 4x plus 1 minus, in parentheses, 2x minus 3. Because the minus actually is a distribution of a negative 1. So distribute this negative to this, you get 4x plus 1 minus 2x plus 3. And then if you do the math here, you get 2x plus 4 over 2x minus 1. And you're going to leave it that way because you could technically factor off a 2, but there's no need. You just box this answer, Okay, and that would be it. That would be your work, okay? If you have any questions, please feel free to ask. Oh, also, you could ask questions about last homework. I forgot to mention that. So if you have questions on homework 13, please feel free to ask them. Otherwise, we're going to continue on. So, now we're going to find the least common multiple. This is the simplest form, though. 2CO2A, okay. I'll look at those. We'll talk about those with you. And simplest form means there's nothing you could actually divide out, okay? Now, you can't divide out a 2 because it would give you a fraction, so we don't want that. Okay, we're going to go on to example 2. Now, least common denominator, this is in the book, of 2 or more rational expressions is the product of a factor to the denominators of the rational expressions with each common factor only used once. What's that mean? It's a lot of words. We prefer not a fraction. It's possible. I don't want a fraction, so let's just say there aren't going to be fractions. Okay? I mean decimals. There are not going to be decimals in a fraction in the numerator. Now, that's usually not simplest form. That's actually a key later on in math. If any of you want to get ahead over the summer and your parent wants you to do something productive, just let me know. I can get you some problems that'll help you in geometry and stuff like that. Okay, least common denominator. We're going to look at the two denominators. Okay, so 4r and 10r squared. And we're going to write them as a product of prime numbers. So 4 is a product of 2 times 2 and r times r. 10r squared is a product of 2 times 5 times r times r. So, what you want to do to get the least common denominator is you only want to get what both have once. So you see how both of these have this 2 right here? And just circle this, and they both have this r right here. So we're going to write these 2 times r, okay? Then we have to write everything that wasn't included. So this times 2, times 5, times this extra r. So 2 times 2 is 4 times 5 is 20. R times r is r squared. So the least common denominator is going to be 20r squared. Okay? Let's take another example. We're going to just do a couple of these because I know this is not what we're used to, right? Okay. So, sorry, ants. I know you're looking for food. It's just you're on my table. Okay. 28m m plus 1 over 7m cubed. Okay, so for this, we're going to look at both 28m and 7m cubed. So 28m is a product of 4 times 7, which will give us 2 times 2 times 7 times m. 7m cubed is a product of 7, I'm just writing it underneath for my own sake, times m times m times m cubed. So what's common between both of these? Well, this 7 right here, this m right here, okay? So we write those two, 7 times m, then we write everything else, times 2 times 2 times m times m. So we get 2 times 2 times 7, 2 times 2, 4, times 7, 28. M times m is m cubed. So our answer is 28m cubed. And that's our least common denominator. Now, is there another way of doing this? If you can do it in your head, that's reasonable. Some of these, like, you can see, okay, 7 goes into 28, so 28 is going to be the least common multiple. M and m cubed is going to be the greatest, it's going to be the least common multiple because they share the same factors. Okay, but some of these aren't going to be that clear. So let's look at another example. What about x minus 3 squared and x squared minus x minus 6? Okay, so first this one should be factored. First this one should be factored and we'll break this apart. So this being factored, okay, guys, a lot of people have trouble on this. If there's not a 1 here, something different is happening, okay? There's a 1 here, we just check what goes into negative 6, negative 2 and 3, negative 3 and 2, 1 and negative 6, negative 6 and negative 1. Okay, and this is the only one that makes sense, so we get x minus 3 times x plus 2. This, if we break it apart, is x minus 3 times x minus 3. Okay, now what factors do they share? They both share this thing right here. So write that, x minus 3. Then we write our others, so x minus 3, there's two of them, and x plus 2. So our greatest common factor, we could turn this into a squared, so it could be x minus 3 squared times x plus 2. Both of these are the same answer. Well, they're both correct. Okay? Okay? Okay, so they both share one factor, so we only need to write that factor once. Okay? If they share something, you only have to write it once. If they don't share something, let's do c minus 2 and 2c plus 7. So if these two don't share any common factor, then you just multiply them. So you get c minus 2. Let's write this so that it doesn't look like a c. Two c plus 7. Okay? And that would be your answer. Okay? This would be our answer. Okay. Let's look at some least common denominator. So we're just looking at the denominator, okay? We're not caring about the numerator at all in this problem, okay? Denominator. So what's the least common denominator of x squared plus 4x minus 5 and x squared plus 7x plus 10, 5a over a plus 3, a plus 6 over a minus 4. So we're finding the least common denominator for these two problems. Okay. 1 minus 1 is 0. Yes, that is a true statement. Don't know how that applies. Okay, so find the least common denominator of these two problems and these two. And I'll play a very short song while you do it. It's worth giving you this time to try it, okay? I don't really pay attention to it. I actually don't see those. It's probably the two people who would probably troll me, but they won't reveal themselves. So okay, denominator. We're looking at these two, and so we have to somehow. One is me. Why are you disliking me? Okay, we're gonna factor this and factor this. So squared plus 4x minus 5. So what we're going to do is look at what goes into negative 5. That's going to be 5 and negative 1, which will actually work. So you'll do x plus 5, x minus 1. And then this one, what goes into 10, where there's 2 and 5. And that's what works. So you're going to get x plus 5 times x plus 2. The order doesn't matter, but finding least common. So you gave one dislike because there was one like. Yes. You Thanos'd my stream. Okay, so they share x plus 5, so you write that once, x plus 5. And then you write the ones that they don't share, x minus 1 and x plus 2. And that will be your least common denominator right there. Okay, what about this one? Do these two share any common? No, so you just multiply them together. A plus 3 and a minus 4. So if they do share something, you need to only write it once, like this right here, this example right here. If they don't share any common, you just write the factors of each. Okay? Example is like 2 and 5. They don't share any common, so you just multiply 2 times 5. But 4 and 2, a better example is a 6 and 4. 6 and 4 share 2, so the least common multiple is actually 12, not 24. So it's just smaller. Okay, moving on. Okay, now we're going to hit the big boy stuff. So example 3 through 5 is the meat. We were cooking the meat. So I always use meat analogies. Maybe I should use a different analogy. Let me think of a different analogy. Let's say you were cleaning your room. I know, it's ridiculous. You were cleaning your room, would you? And you were just like, okay, where do I start? It's such a mess. I don't know how to clean it up. So 1 through 2, we're setting up where next 15 minutes, so 45-minute lecture. Yeah, 45 minutes. I can finish in 15. Okay. So 1 and 2 would be you figuring out, laying out how to clean up your room. 3 through 5 is you actually doing it. So my conclusion is the whole point of this was basically to get Woonju to clean up his room. This is brought on to you by the Parent Foundation. Okay, so the first step is finding least common denominator of 8x squared and 12x cubed. You don't have to write this down, but I will, okay? So 8x squared, 12x cubed, you get 2 times 2 times 2 times x times x. This gives us 2 times 2 times 3, x times x. Okay, so what do they share in common? Well, they share these two 2's and these two x's. So you get 2 times 2, x times x, and then we write everything else. 2 times 3 times x. So 2 times 2, 4 times 2 times 3, 6. 4 times 6 is 24, x cubed. So that's the least common denominator. Now, we need to figure out what this needs to multiply to get into this. And what it needs to multiply is by 3x. And what does this need to multiply by? It needs to multiply by 2. Okay? So to find your least common denominator, you find out how each thing multiplies into it. Then you multiply the top and bottom by that part. So 3x times 9 is 27x over 24x cubed, plus 5 times 2 is 10 over 24x cubed. Is the denominator the same? Yeah, so we can add the top. 27x plus 10. Okay? So how I got from here to here is I divided 24x cubed by 8x squared. Okay, I divided this by this to get 3x. And then I had to multiply top and bottom by the same number. Okay? So this is our answer. And we're going to move on. Okay? So example 3, we're going to go to example 4. Honestly, your examples are in the book. You feel free to reference them. They're very important for some of the problems. So, yeah. Very important versus somewhat for either. Yeah, that's the spectrum there. Okay. So, we have to find the least common denominator. These two do not share a common denominator. Okay. Real quick. I'm going to show you how I got that. So I had 9 over 8x squared plus 5 over 12x cubed. And our common denominator is 24x cubed. Okay. How many times does this go into 24x cubed? That goes by 3x, right? How many times does this go into 24x cubed? Times 2. So then I multiply this by 3x. I want to get the same denominator. Then I multiply this by 2 over 2. Okay? So it's what does this denominator need to multiply by to get into 24x cubed? Okay? So, yeah, it's helpful. Okay, these two don't share a common denominator. So you actually just have to multiply 3x by x plus 2 and x plus 2 by 3x. So 3x times x plus 2, but you have to multiply on numerator and denominator. And x plus 2 we need to multiply by 3x. Okay, to get the same denominator, we just need to multiply these two together. So 3x times x plus 2, and the top is 10x plus 2. Now you can already distribute. You have negative 7x times 3x over 3x times x plus 2. So I'm going to distribute. So you get 10x plus 20 minus 21x cubed. And do they have the same denominator? Yeah. What's our denominator? We'll distribute. We get 3x squared plus 6x. Okay. This is squared. Sorry. I don't know why we're cubed. Squared. This could be written in a different order, so we'll write negative 21x squared plus 10x plus 20 over 3x squared plus 6x. And this is our denominator, and we're going to check it in the book, and that is accurate. Now, the book doesn't distribute this, and it's up to you. I do think it's worth distributing these ones. That's what the book does too. Okay? So, they don't distribute the bottom, but you can. Okay? Okay. So, you need the same denominator to add fractions. Okay? You need the same denominator to add two fractions. Or subtract them, okay? you don't have the same denominator, that's not possible. Okay, now, the meat. X plus 4 over x squared plus 3x. 1 second. I don't know who that is. Actually, I think that's not important information. Don't ask me why my phone just went off, but it did. Okay, so we need to factor these before we can find the least common multiple. We need to factor these before we can find the least common multiple. Yeah, my phone went off. That's about it. Okay, factoring this, we can get negative 2 and 5, and that works. Negative 5 and 2, so this works. So we get x minus 2, x plus 5. This factor, you get negative 2 and 4, or negative 4 and 2. First thing works, so you get x minus 2, x plus 4. So what's shared is this thing right here. So what they both go into is x minus 2, x plus 5, x plus 4. Now, here's the question. What does this need to get to become this? So how do you go from here to here? You go from this to this. You need to multiply by x plus 4. How do you get from this to this? You need to multiply by x plus 5. Okay? So this one, this whole fraction, is going to need to multiply by x plus 4. This whole fraction is going to need to multiply by x plus 5. In the classroom, would their suits necessarily? What suits? Should I wear a suit? I'll wear a suit for next lecture, just for you, won't you? Oh, no, teachers don't record it in their classroom. I'm the only one who's in my classroom. Okay, so we're going to multiply this one by x plus 4 over x plus 4. We have to multiply the numerator and denominator by the same. Okay, this one is x plus 5 over x plus 5. I don't know what your y question is to. Is your y question to the math-related thing or to something else? Okay, so we multiply the numerator, x plus 4 times x plus 4. So you get x plus 4, x plus 4. The denominator is x minus 2, x plus 5, times x plus 4. Now this is just what we did, what our goal when we were finding the least common denominator. This is x minus 1 times x plus 5 over x minus 2, x plus 5, x plus 4. So first step is to multiply these two, and then combine them. It's x plus 4 times x plus 4 is x squared plus 8x plus 16. And you still write the denominator before you combine them so that you keep track of it. This becomes x squared plus 4x minus 5. This is the same thing, x minus 2, x plus 5, x plus 4. Okay, combining this, we subtract x squared, so that cancels. Subtract 4x, that becomes 4x, and subtract negative 5, which will become positive 5, so 16 plus 5 is going to be 21. final answer is going to be 4x plus 21 over x minus 2, x plus 5, x plus 4. Okay. Okay. And we check, is that what the book got? Yes, that is what the book got. So they show their work up here. Here, let's just zoom in for a second to the work that they did. So you can see that it is the same thing. So they found the common denominator, right over here. Then they multiplied it, top, multiplied this top. So they combined them, multiplied, subtracted this from this. Okay? And then they got 4x plus 21. So we are finished with the problems, but we could do a practice problem. It's up to you. Would you guys want to spend 3 minutes? I'll give you 3 problems right here, and then you can finish them, and then I'll just write the yay, no. What's no? Diane, you guys got to few sentences. I can't read your mind. I don't know what you're referring to. Because there's a delay to the there's a delay to the chat, so I can't tell which thing you're saying it to or no. Okay, I'll do 3 practice problems, and I'll give the solutions. And if you want to stay a little bit longer, I will explain 2 questions from the last homework. So I'll give you a few minutes for this. You can actually just pause the video and spend as long as you want if you're not watching live. Actually, that's true. You could always pause the video and okay. Here's 3 problems. Can you just do 2? Yeah, choose 2 of the 3. Although granted, I would suggest to do the one that you need the most help with. So choose 2 of these 3. I will show all the answers. Okay, I'll give you a minute or 2, a few minutes. I'll put some music on, and then Okay, I'm just gonna kind of show you the solutions here, and then I'll go over, oops, when did I do that? Okay, hold on. I'll go over some of the problems from the chapter, okay? Okay, the first one, the least common denominator, is going to be 10x to the 4. So the first one needs to multiply by 5x cubed and 5x cubed. This needs to just multiply by 2 over 2. So we get 15x cubed plus 14 over 10x to the 4. Okay. This one, the denominators are two different things. They have no common factors, so you do y plus 1. Sorry. First one you multiply by y plus 2. Second one you multiply by y plus 1. So it's only if they share no common things do you multiply them straight together. So this becomes y squared plus 2y, and then this is plus 3y plus 3 over y plus 1 times y plus 2. The top becomes y squared plus 5y plus 3 over y plus 1, y plus 2. Okay, the denominator that you're looking for is z minus 2, z plus 4, and z plus 2 is your common denominator if you factor both of these. The first one you need to multiply by z plus 2 over z plus 2. The second one you need to multiply by z plus 4 over z plus 4. If you do it, you get 2z squared. In the first one, you get 2z squared plus 3z minus 2. And then we're going to subtract z squared plus 5z plus 4. And then our denominator is z minus 2, z plus 4, z plus 2. If you cancel, you get, cancel this. There's a lot of stuff going on here. So if you cancel, get z squared minus 2z minus 6 over, and then the parentheses z minus 2, z plus 4, and then z plus 2. There's your answer. Okay. If you are confused about the process, the book has some other examples that you can refer to that would be helpful. Okay. So we're going to go over the book over here. The questions I gave on homework. Sorry, not the book. So, question 1a is find the product. So you just need to factor. You can factor first, or you can multiply first. Factor first, and then you're going to multiply and then cancel. So you're going to simplify. Oh, there's no 2a, there's no 2c. There's 2c and 2d. I mean, unless I'm mistaken. Hold on. Double check. So, you know, sometimes I give you guys homework that not turn it. Yeah, let's look at this. Yeah, there's no 2c. There's 2c and 2d. There's no 2a. There's 1a, 1b, 2c, 2d. We're finished with the lesson. So, that's the end of the lesson. There's no word problems this chapter because that would be unreasonable. So this is homework. We'll talk about 2c. So 2c, we need to factor first, then divide. Okay? So factor first, then divide. Okay? So if we factor first, I'm just going to write the problem out. Okay, that was not what I wanted to do. Yeah, sorry, hold 1 second. Okay. Okay. So you have x squared plus x over x squared plus x minus 30 divided by x minus 6 over. Okay. Now this can be factored. You can factor out an x plus 1. Bottom, you can factor, this would be, negative 5 and 6 makes sense because this is positive 1. So x minus, you get x minus 5 and x plus 6 divided by, so x minus 6 is going to stay the same. And then the bottom is x, it's going to be negative 5 and negative 6 because this is positive and that's a negative. Now, could you simplify this to start with? Yes. So divide means we flip it and multiply. X minus 5, x plus 6, and we multiply by x minus 5, x minus 6. Okay, and then you're going to multiply them together and then cancel the common terms, okay? Common terms have to be in parentheses. They have to be factors, okay? Not in parentheses, but they need to be multiplied, okay? It has to be products, okay? So there's some stuff that cancels, like this negative 5, that negative 5, this negative x minus 6, this x minus 6. So x minus 5, x minus 5, cancel. X minus 6, x minus 6, cancel. So then you're going to be left with a smaller thing. Yes, you can. You could switch this division into multiplication and then factor. The steps, those two steps are not, they don't require order. Okay? So you're going to simplify it. I'm not going to show you what the answer is. Okay? Because there's only 4 questions, so I don't think it's appropriate for me to show you the answer to 1 question out of 4, or 2 questions out of 4. But I kind of did show you the answer, if I'm honest. Okay, people who struggle with factoring. This is a problem where you need to be careful how you factor this. Okay, first step, when you have this parentheses, is always put it over 1. Once you put it over 1, then we can switch this into multiplication. So we get 1 over 2k plus 5. Okay, now factoring this, if you do 4 times negative 15, you get negative 60. Then what goes into negative 60 is 12 and 5, that doesn't work, is 6 and 10. So 6 is going to be negative because the middle is positive. So they need to add up to be 4. It doesn't matter, they're the same answer. Okay, so this is what we do. Now guys, a lot of people struggle with this. You need to break the middle into this. So it should become 4k squared minus 6k plus 10k plus 15. Sorry, that's out of frame. Hold on, I'm just going to do it over here. So if I was factoring this right here, 2 2k minus 3. If I was factoring this, I would turn this into 4k squared minus 6k plus 10k plus minus 15. Okay, then you group the first two and the last two, factor off what you can, which is 2k. So you get 2k minus 3 plus, factor off plus 5, 2k minus 3. Is the inside of the parentheses the same? Then this is 2k plus 5 times 2k minus 3. Okay, so that factors off, and then you should be able to simplify, okay? Okay, guys, make sure you factor properly, make sure you multiply correctly, and I'll post the homework shortly. Test will be next Monday, or I'll give you an update about it. Okay? Bye, guys. Have a great day.